Okay guys, so this is a video of the semester review to show you how to work these out if you needed some help. On the first one, it says a resultant force of 10 newtons is made up of two complete component forces acting at right angles. So we know that they are acting like this. And we know that one of them is 6 newtons. And we know the resultant should be 10 newtons. Which means that the hypotenuse here should be 10 newtons. So the way we do this is we would just do 10 squared minus 6 squared equals whatever the other part is. We'll call it y in this case just because that's the one that I left blank. And so we would get the square root of 10 squared minus 6 squared, which is 8. And so the answer should be 8 newtons. Okay? Number 2, two forces OA and OB act simultaneously at point O shown in the diagram. The magnitude of the resultant forces is closest to, and it should just be 8 newtons and then another 8 newtons, and you're trying to figure out the resultant, so it's just the Pythagorean theorem, which is 8 squared, 8 squared plus 8 squared square rooted, which is 11.3 newtons, or B, 11. Number 3. Which pair of concurrent forces could produce a resultant force having the same magnitude, having a magnitude of 10 newtons? Alright, first let's rule some out. So it can't be B because 10 and 30 can never be smaller than 20 newtons. Because the smallest possible would be if you did 10 this way and 30 back this way, and the smallest that would give you would be 10. For the same reason, C and D are out, because if you add up these two forces, the max they could possibly be is 9.4 and 9.7, and so you couldn't get it that way either. So the only answer left is A, and that's because you could draw them in such a way that you could get 10 newtons. You could draw it with a 60-60-60 triangle and get 10 newtons on every side, and that one would work. So it's A. Number 4, the graph represents the motion of a cart. According to the graph, as time increases, the speed of the cart would. First of all, this should be listed as distance over time. All right. So it didn't label that, but if that is distance over time, it should remain the same, because if the distance is increasing at a constant rate, then the velocity has to be constant. So the answer should be C. The speed would remain the same. Number 5. All right, this one says that gives you this graph, and it asks you how far did the cart move in the first 5 seconds. Well, the graph in the first 5 seconds shows this. Alright, that's what the graph looks like in the first 5 seconds. And the top point is 20 in the y direction, and the x points are 0 and 5, obviously, because it goes from 0 to 5 seconds. So this is a triangle. The area under a triangle on a velocity versus time, the area equals the distance. So you do 1/2 times 20 times 5. And you should get the answer of 50 meters. Okay. Number 6, find the acceleration of the cart at 6.3 seconds. Well, at 6.3 seconds, we're going through a phase where we're going from 20 down to negative 20 on the graph. So it's part of this line, and so we care about what's going on in this line. Well, this line starts at time 3, and it goes through to time 7, which gives us a change in time of 4 seconds, and we have an initial velocity of 20 and a final velocity of negative 20. So we do A equals Vf minus Vi over T, and we get A is equal to negative 20 minus 20 over 4, and we should get A is equal to negative 10 meters per second squared. Okay, Number 7. The graph shown represents the relationship between distance and time for an object in motion, during which interval is the speed of the object changing. So the answer should be from D to E, because if it's a distance versus time graph, remember that whenever you have it curved, the velocity has to be increasing at a constant rate. So the answer again should be from D to E. Number 8. There is a mistake on the answer sheet. This answer should be B, not A. So it should be B, because if you go 98 meters in 10 seconds, the average speed is just distance over time. So it should be 98 over 10, which is 9.8 meters per second, equals V. And that should be B. So it should be, the answer should be B. Number 9. A jogger accelerates at a constant rate as she travels 5 meters, so a distance equals 5 meters, along a track from point A to point B as shown. Her initial speed is 2 and her final speed is 3, and we want to know how long this took her. So we want to know time. And so what we've got to do is, we can use all kinds of formulas to do this. I think the easiest one to do would be to do distance over time equals VF plus VI over 2, and we would get 5 over T equals 3 plus 2 over 2, which would give us 5 over T equals 2.5, or T is equal to 2 seconds, which is the answer B. Alright, number 10. A car accelerates uniformly from rest to a speed of 10 meters per second in 2 seconds. The acceleration of the car is, well, we know VI is equal to 0 and VF is equal to 10. So we know time is 2. So we should do A equals VF minus VI over T, and that should be equal to 0 minus 10, 10 minus 0 over 2, and we should get A is equal to 5 meters per second squared, which is B. So number 10 should be B. Alright, number 11. An object falls freely from rest for 3 seconds. The acceleration of the object is. It's kind of a trick question. The answer should be B, because acceleration should be the acceleration due to gravity, which is always negative 10 meters per second squared if we include the direction, but just as the magnitude itself, it should be 10 meters per second squared, which is B. Number 12. Which combination of graphs best describe the free fall motion? So free fall motion is, first of all, where the distance, we have to have the distance increasing over time. So it's got to have B in there, and then the speed should also increase over time, but at a constant rate. So the answer to number 12 should be B, both B and D. Number 13 says, an object has a constant acceleration of 2 meters per second, and what is the time required? The time required for the object to accelerate from 8 to 28 meters per second is. So we know the acceleration is equal to 2. We know VI is equal to 8 and VF is equal to 28. So we're going to do A equals VF minus VI over T. So we get 2 equals 28 minus 8 over T. And we should get T is equal to 10 seconds, which should be the answer choice C. So 13 should be C. 14. A locomotive starts from rest and accelerates at 0.12 meters per second squared to a speed of 2.4 meters per second in 20 seconds. This motion could best be described as, the answer should be C. It's got a constant acceleration and an increasing velocity. 15. The diagram pictured shows speed as a function of time for 4 cars, A, B, C, and D. Which car experiences the greatest acceleration during the 6-second interval? We're looking for the average acceleration. So the answer to number 15 should be car D, because it's the one that grows the most over time. Despite the fact that it levels off at the end, it still should be car D. Alright, number 16. The displacement time graph shown represents the motion of a cart along a straight line. During which interval was the cart accelerating? And number 16 should be the part where it's curved. Remember, if it's distance versus time or displacement versus time, a curved graph indicates acceleration happening. So what you want to do is find that, and that's from A to B, so the answer should be A. Number 17. Which mass would have the greatest acceleration if the same unbalanced force was applied? Well, remember F equals ma, and so if you had the same force and you were changing the mass, which one would have a greater acceleration? So if we change the mass, look, to solve for acceleration, force divided by mass would equal the acceleration. So the smaller the mass, the bigger the acceleration would be, and so the smallest mass there is A, one kilogram. Okay, number 18. A test booklet is sitting at rest on a desk. Compared to the force of the booklet on the desk, the force of the desk on the booklet is the same. This is Newton's third law. For every action, there is an equal and opposite reaction. So if you're putting a force on the desk is putting the same force in the opposite direction onto you. Number 19. Bad question. But the point that it's trying to make, that it does not establish because it left out some things, is that it doesn't matter what surface it is. If they're moving at a constant velocity, then what that means is that the acceleration is 0, and therefore the sum of the forces should be equal to 0. So whatever force you're applying should be counteracted by a frictional force. So it's whichever ones, there's not an answer here, but let's say that there were two that were both pushing with 4 newtons. So if I'm pushing with 4 newtons and 4 newtons, they should both have the same frictional force because there would have to be a 4 Newton force resisting them. Number 20. Which graph best represents the motion of an object falling from rest near the Earth's surface? This was another one that has a bad question. It should be C. The speed should increase as it falls. Okay? So I think in the back it says something else, but the answer should be C. Alright, I'm going to pause right here and then make another video with the rest of these. So hopefully this helps some people out.